Hi everyone. So today we are going to talk about GraphQL and serverless. What GraphQL is and why it goes well together with serverless approaches. So before I start, let me take a quick temperature of the room where you all are regarding to GraphQL. And if you take your phone, go to this QR code, then we can have a quick check. Just 2 questions. Awesome. Okay, I think let's start. So first question, have you heard about GraphQL before? Are you using it? Do you have it in production? Experimenting with it? Awesome. That's, by the way, the typical .NET result for this. If I do that at a JavaScript conference, you would see the green and the pink bar much higher. Okay, second question. How long do you think is GraphQL already alive? Interesting. Awesome. That's also a typical result of this. Not only in GraphQL, in general, people think GraphQL is around 5 years old. But actually, it was created back in 2012 by Facebook. And they initially called it Supergraph for lack of a better name. It was created by 3 people that were in charge of figuring out what is wrong with their mobile applications back then. There was Nick Schrock, Lee Byron, and Dan Schaffner. So what is GraphQL? Or better, why is GraphQL? And to answer that, we have to look a bit at what problems Facebook was facing back in 2012. So back in 2012, maybe somebody remembers, they were introducing a new mobile application. And this mobile application actually didn't look like this. It looked more like this. Faced a lot of backlash because it has had several issues. And these issues were around that the app startup times were very slow, and that it used a lot of data. And back then we didn't have these generous data plans with gigabytes. It was more like maybe 500 megabytes or so. And on top of that, it drained the batteries very quickly. So the Facebook team, by the way, this is how the newsfeed looked back then. Also a nice, ugly application. So the team back then analyzed what is the problem, and what they found out is that they actually used all the techniques that they used for their Facebook web application and applied them to their mobile application. So they used HTML because they were expecting HTML5 already back then and the HTML5 features, and they were like hyped about that you could use HTML to build mobile applications. Things that we do today, but they didn't work out back then. And also they used in the backend REST, and that was a major problem for them because REST was not optimized for this mobile needs. So when they looked at the requests that they were doing, so when they basically started up the application, they would maybe fetch the current user that is signed in, and they would get the same response back that the desktop application got back. So Actually, the mobile application just needed 3 properties, but this request actually had over 60 properties. So a lot of data that we had to consume, because at some point the backend engineers defined that this is what you need when you log on, right? And the second thing here is that they actually needed more data. They don't just want a user name and a user picture, they actually wanted the news feed. So they had to first get this first request, grab from that some ID, pass that in the second request, and then fetch the newsfeed. And for the newsfeed, we had the same problem. For the mobile application, we had a very small viewport. So we maybe wanted the story, the text of the news, and then we might want to have a picture or the author who wrote that, a picture of that author. But the news endpoint just provided us with news data. So we had to grab some IDs here from the author and feed that into the next request. And again, this request was also not optimized on mobile applications and gave us a lot of properties that we didn't need. And we actually just, again, needed 3 properties to get the profile picture and the name. Such a thing looked probably like this. It's not from Facebook. I just re-engineered this data waterfall. This is how we call that. There are a lot of consecutive requests that you are actually doing because REST is designed around the concept of resources, where you have a user resource, a news resource, and everything is nice encapsulated. And the problem here is that you cannot parallelize these requests. You have to always wait for the previous request to get some ID from it, to feed that in the next request, and that slows your APIs really down. So the 3 people at Facebook sat down and rethought the concept and said we need to reverse the responsibility and give the client the power to ask for what it needs. So this is a GraphQL query. You could say the hello world of GraphQL. In this query, we are asking for the currently signed in user and for the name. And if we send that to our server, we get exactly that. A JSON that closely aligns to our request structure and gives us exactly the data we asked for, not more and also not in a different shape. And as our components change or our use cases change or the devices, we can ask for more or less data. In this instance, we are also asking for the profile picture and some details around that. And as we might already expect, if we send that to our server, it will respond with exactly the data in the shape and structure we wanted. And if we look at that, we actually think that's actually great for relations. So if we have related data, connected data in our graph, like the news or the friends, like think about the Facebook application, we have these friends lists, we could fetch that in one go. When our application starts, we do a single HTTP request to our backend and fetch all the data we need. But we also see some repetition here, like name and last seen is used duplicate times. And we actually could use something in GraphQL that is called a fragment. And that is our primitive for composition in our client component. It's essentially the client contract for your React component or for your Blazor component or whatever you are using. We're not talking about the client side so much, so let's move on. So the main concept here is GraphQL gives the consumer the power to ask for what it needs, and you get nothing more, exactly what you need. So what is GraphQL? GraphQL is a query language for your API. It doesn't have to do anything with graph databases, nothing to do with databases actually. It's a query language on top of your API and runtime to execute those queries. And it allows you to expose your business layer in a much richer way with interfaces, unions. So you have a no compromise way to expose your business layer to other people. So with GraphQL, we have a single endpoint because we are telling that endpoint what we need, so we don't need all these multiple endpoints. And we can fetch all the data that we need in one request. And that is very powerful. This allows for no overfetching or underfetching. This overfetching was when I had to consume the properties from a request, from an endpoint, that somebody designed for a complete different use case. So I had to swallow all that data that I didn't need. And underfetching is when I don't get enough data. All those IDs in these requests, that are points, connection points that I actually wanted to have. I don't want this ID. I want the freaking name of this username, of this user. And on top of that, GraphQL is built on a strong type system that allows you to have a real, much richer way to expose your business layer. And that makes GraphQL really predictable to use. And on top of that, it's real time. And we will have a look at how we can make it real time with serverless today. Okay, so before we look at the first piece of code, this is the basic 3 operations that you can do with GraphQL. We have read operations, we call them query in GraphQL. And it is basically the get in REST if you design your REST API well. Then we also have mutations that are write operations causing side effects to our system. And it's basically the put, post, patch, delete in REST. Last, we have events, or we call them subscriptions in GraphQL, and you don't have them in REST. You maybe have them by using SignalR or WebSockets or so, but in GraphQL they're integrated. So writing a query is no different from writing a reactive subscription. Okay, let's have a quick look how GraphQL works. And this first example we are just doing with simple ASP.NET Core. So if we wanted to create a GraphQL server, we could start just by creating a new web application. So I could say .NET new web, and then I need a single package to add GraphQL to it. So I would do hot chocolate, add hot chocolate, and let's take a preview. And now I have everything ready to build a GraphQL server. So I said we have this query type, a query root operation type, or these root operation types. And that's actually how I build a GraphQL server. So I would start maybe with a class query here. And let me just put in a simple query here. So it's a simple class. We call that query. And maybe start with a hello world here. So we do public string, and then we say hello. And that maybe has an argument here that we call name. And has maybe a default called world. And then we do some string concatenation here. Hello. And then put in the name here. Okay, that's a good start. This is actually all we need for a GraphQL server. There's now just some configuration needed. So we go here to our program CS, like every other web application. And then we configure our GraphQL server. And we're using the builder here and the services. And then we just say add GraphQL server and then add query type. And then we're just pointing to that type that we just created. There's one more thing needed here, and that is mapping the transport. So we go down here and say map GraphQL, and then we are actually done. We can run that thing. Oh, password. Unexpected. Yes, allow. Okay, so my endpoint is up. I cannot just grab it here. No, then let's take the HTTP. And you see it's a 404, there's nothing there because GraphQL is always, or by default, hosted on the GraphQL route. And now I'm greeted here with Banana Cake Pop. That's our GraphQL IDE. Let me zoom that in a bit so that we can all see better. And the most important feature here is that it can raise down the glasses. No worries. Okay, so I can open here a new tab, and now I have my GraphQL schema, which I can look at. And what I meant with exposing our API in a much richer way is that our C# code just translated one-to-one to GraphQL types. So you can see I have a say hello here with a string that is returned. It's a non-nullable string, so the non-nullability is correctly inferred. And I also have here my argument and even my default value. So if I use that now, I can ask my server to say hello to me, and it would say hello world. And I have an argument, so I could override the default value here and say hello Michael, and it works. And this is very clean. That's the it's very clean to use. Okay, let's go back to the slides. Let me just get rid of that and go back to the slides and recap that a bit. So we created a simple class in C# that we called query and registered as our query root type. So this is the entry point for our GraphQL server. From there we can expose everything we want, and it will be inferred as GraphQL. We call this method in our query class a resolver. And from that resolver we infer actually the GraphQL type, and we call that the annotation-based approach. This is the original GraphQL approach that Facebook came up with. They didn't want to have a second specification language. They wanted their developers to write code, and this code exposes your service layer. So, okay. And if we look at the GraphQL type here, the hello, we call that the field on the GraphQL type, and a field is like a method or function in C#. And fields can have arguments, just like methods, and also default values. In fact, GraphQL even can have objects as default values, so it can do more than C# in that regard. And also, one important aspect with GraphQL, types are nullable by default, and they are non-nullable if we put an exclamation mark on that. So this is not a non-null forgiving operator. That is different in C#, where we put a question mark on a type to make it nullable. So it's reverse. Okay, so GraphQL is transport agnostic. That's important to know. You could write the request in a file, read it, and then output it in a file. In general, we have HTTP, WebSockets, server-side events, or gRPC as a transport. The most common case is HTTP post, and that works very well with our serverless functions. But we also can use server-side events for subscriptions, and we will use that in our Azure Function later. Okay, let's talk a bit about serverless. What is serverless? So, first thing, serverless still has servers, so it runs on servers, but the concept is that we don't think about servers anymore. So, we don't have to manage or provision any servers. We just think about our application logic. And that means we also don't have to think about scaling the thing, because it scales automatically. If there's more demand, we just get another function instance. And also we don't have to care about high availability and this stuff, because it's abstracted from us. So the serverless solution will handle that for us. And we don't have to pay for idle, and that's why it's very attractive for startups or people who have a small side project, but then scales also all the way to very heavy load. So it's very easy and very tempting to start with serverless. And I don't know who here worked already with, or still worked with boxes at the office. So when I started my career at a web agency, we actually hosted for our customers the stuff in our office. So next to my office was a server rack. I don't know if that was that secure and like today in Azure, but we did all this stuff on our own. So with the dawn of AWS and Azure, we actually got infrastructure as a service and platform as a service, and gradually had to manage less and less of our infrastructure. With serverless, we now really focus on our application logic, and even that is simplified. There's only one thing that could be more simple, and that is SaaS solutions, but then we don't have to write any more code. So with serverless, we are abstracting or we simplifying our application logic to a function. So a function doesn't mean that there is only one function. It could be a whole server in there, but the form of abstraction is a function. There are a couple of frameworks out there, and these are the four most popular things. So there's serverless, which is a huge open source framework which works on AWS. There's AWS Lambdas, and they are really easy to use. You essentially can just throw your ASP.NET Core server at them, and they will work. But what we are looking to do today at is the Azure Functions. Okay, Google Cloud I never used. They have it, but I don't know. So who's using serverless? I said startups or things like that, but it's not just small companies that try to save money. It's also big companies like Netflix that have huge requests and want to have this dynamic scale. And that is the reason to have that. So Netflix, for instance, uses it to encode their films, or that is their movies, and that's where they started. So if someone like Disney uploaded video material to them, they would use serverless functions to encode them. Nowadays, they are using serverless more and more, and they are also one of the biggest GraphQL users. So if you are using Netflix, you are actually using GraphQL in the backend. Another company in this regard is Coca-Cola. I haven't looked in what they are doing with it, but there are a lot of big companies that are investing in serverless. Okay, let's have a look at Azure Functions, and before we run into the next code example, just let's reflect a bit on their plans, because that is about payment and scale. So they have actually 4 plans, and the consumption plan is if you want to start cheap, because you don't have to pay when nothing runs there. But they also come with a little detail that if there's nothing running and the first few requests come in, you have a longer startup time. So we call that a cold start for this Azure function. You can also go for the premium plan, and that has pre-warmed instances, but then you pay also for the pre-warmed instances all the time. Last but not least, you could just use the model of Azure Functions in your service plan. Maybe you have also already web applications, so you could just run a function in your app service plan, and then you just pay your app service plan. It's more about then that it's simpler to program these. Last but not least, and that was in preview, I didn't look up if it's out of preview, it's function for Kubernetes. So if you have an AKS on Azure, you could use them in there as well. Last but not least, there are 2 hosting models, and they are a bit confusing in .NET. That's why I cleared up for you. So there's in-process model. So the in-process model is essentially the legacy model, but it has some benefits to use that. So the drawbacks are you're running in the same host of the Azure function, and that means you have to be a bit more careful at what assemblies you're using, and the DI is actually drylog and not the standard DI that we use in ASP.NET Core. But it uses the HTTP request, so you have direct access to the transport. And also you have access to the cancellation tokens, and that means you can cancel long-running requests. This is good for real time. Whereas the hosting models, you are freer what to use. You can use any new ASP.NET, any new .NET version, but you don't have cancellations, and all the request responses are actually marshaled. That means you cannot use streaming solutions here. But you have your standard DI. Okay, let's have a look at how we can bring that in. So there is, let me notch that up a bit. Okay. And let's go to demo 2. So how to get started with Azure Function. You can install the hot chocolate templates here, so that in order to get the Azure Functions templates, and it's quite simple. You do .NET-I and then hot chocolate templates, and then you just install them. I already have them installed, but we could just, let me fix that so we see that. Just delete them, and hopefully I have internet to get them back. So we have 3 templates here, 2 for Azure Functions. One is for the in-process model, and one is for the isolated model. And then you also have the GraphQL for ASP.NET Core. So what we're going to do is use this first model here and just quickly craft a simple Azure Functions and have a look at it. So I'm doing just this simple thing here, and then we go with Visual Studio Code into it and have a look at it. So this is my Azure Function, and you can already see it looks a bit different. We have still a program CS here, and they all aligned now. The way you configure .NET consoles. So there's a console builder, there's a host builder in Azure Functions, there's a builder in ASP.NET Core. So they have a very similar concept everywhere. Even in MAUI, if you try out MAUI, they have a builder there. So it's very similar how we configure our startup now. Let me just restore that. Okay. So this should work. The second thing here is my configuration is actually the same. The so the GraphQL configuration is actually the same like in ASP.NET Core. I just have to chain in here my configuration logic for GraphQL, and then I can write my stuff like before. But I don't have to deal with all the transport logic. There's a lot more with middlewares to deal with in ASP.NET Core. So I'm really focusing here on my graph logic. So I'm just building up my graph and putting in my business logic. The function we have already pre-configured and pre-generated here. So we're just calling the GraphQL executor. And let me just quickly run that. So we do func start. That is the way to run your functions. You can also debug them. There is an emulator locally. And then I can just call that up here. And I even have banana cake pop in here. And that's awesome, because when I thought about functions, I only thought about these simple things where I can process something. Okay, there's a function that fetches a message from somewhere and processes this and then gives me a result. But actually you can host a whole web server in Azure Functions and get away with this complexity around hosting it. Okay, so I could query that, works nice. Let's move on, because there is still lots to tell. Let me just get back to my slides here. And go. Okay, so the goals here from combining GraphQL and serverless is that we have a faster iteration speed. Faster iteration speed because of GraphQL, because it decouples the development of applications between my backend and frontend developer. So the backend developer can expose the world, and the frontend developer can now pick from that. And it's a very strong contract that I expose with GraphQL, and the client developer can use static typings to really know what's going on where. So when the client developer crafts queries, it compiles to a very strong client depending on where they are working with. So in Relay, we have very strong clients, and also in .NET Client Solutions. So last but not least, I have a very efficient way to now deploy my GraphQL server and scale it. So if you think also about large graphs like Facebook's graph, which consists of over 10,000 types and 300,000 fields, I can scale that and decompose that in subgraphs, like I have a GraphQL gateway, and only pay for the parts of the graph that are really used. But what about real-time? Because with that, real-time seems difficult. We will have a look at that. But before we do that, let's talk about data fetching. And for that, let me jump into some more code. So this was our first examples. Let's go to demo 3. Okay. So this is, again, a simple Azure function. And I'm using here Postgres. I hope the internet works out, because Postgres is in Azure. And you can see that I have here an empty query type, so nothing there. My configuration is at the moment already set up. Like I have a pooled DB context here, and I'm using there my Postgres connection. The GraphQL configuration is not there yet. So how would I connect something like that? So I use entity framework here. So I have a DB context with 2 entities, and I want to expose them. So I would go here and create my query type. Basic structure, simple C# type. And then I would just introduce a resolver here that fetches the assets from my DB context and just exposes them. So you can see that we are using in GraphQL something we call resolver dependency injection. So we are injecting into our resolver instead of injecting in our class. And we are doing that because these resolvers can be executed parallel. GraphQL can parallelize data fetching, so there will be a query plan created from your GraphQL request, and then the engine optimizes parallel data fetching from your data stores. And that's why we inject into our resolver, so we can rent that DB context from our pool and use multiple at once. Okay, so we just did that. Now we configure it. So I'm going here, and I'm just saying add query type. And then I'm telling my GraphQL server what kind of DB context we actually have here. So I can say register DB context, then asset context. And then I'm telling it that this is actually a pooled DB context, so all the renting and stuff is done by the GraphQL engine. Okay, with that I'm actually done, and I can start this thing. It's func start. I often do the mistake, if you do .NET run, it will just fail. But func start will give us our GraphQL method here. Let me just call that. Is it the same port here? Okay, I refreshed the schema, and you can already see that I have the asset type. But I don't have just the asset type. The GraphQL engine inspected my graph and saw, okay, there's also a related object here. And we could also query for that. So I can drill in the graph. It's just one line of configuration, and already I can use my complete subgraph here. And now I can just drill in and ask for the name and run that. And if the internet is good, it's so slow because it's really running on Azure. And you can see it's already fetching data here with just 2 lines of code that I had to write. But this is fetching the whole database, and this is the right point to talk about. Let me go there. Pagination. And I'm doing it quickly. So in Facebook looked at the pagination concepts, and when they looked at cursor-based pagination, this guy here, they said that never can work for us because they have massive data loads where they get new data every few seconds, and if a user would page the news feed maybe, then it could happen that there's rapidly new data coming in, and if I go from page 1 to page 2, that I have the same data because it's moving in. And that's why they came up with something that we call cursor-based pagination. And that allows me to pin each item. And as new data is coming in, I'm navigating relatively from my entities. And that means as my new data is coming in, my pages as well shift. So I have a consistent paging solution. So how would we implement that with GraphQL? Let's have a quick look. Let me stop that. So I'm going here to query, and then I'm saying use paging. And then we are done. It's more about the concept. Okay, this is rebuilding. I can already go back here to my GraphQL IDE. And now you can see that my types actually changed. And I have this new connection type here, where I have a page info, like am I on the last page or not, what is the end cursor, the start cursor, so I can navigate. And I also have here my assets. So I can now query the nodes, and then let's go again for the name. Nodes. And we are taking the first two. And then again, it's Azure. It's as expensive to query two as it's expensive to query all of them, apparently. But now I just have two items here. So this is how we do paging in GraphQL. Okay, let's go on and talk a bit how that actually works. So I just put this attribute on, and that's actually a field middleware. And how that works is, so when I put that on here, I'm actually creating a field resolver pipeline. And that here is a middleware up there. And our resolver is essentially, first we call the middleware, and then the resolver is also a middleware. So we are building a pipeline with this attribute. And actually, if we put more of these data attributes on here, like a projection attribute that allows us to go into the graph, or filter attribute that allows us to filter this stuff, we are creating a pipeline for this async field to fetch data. And if you know about middleware in ASP.NET Core, it's the same principle. So it works that use paging is called, and that would await the next element in our pipeline until we get to our getAssets resolver, which would return the queryable, and then these data middlewares will apply expression logic on top of our queryable. But it does not only work with queryable, it works actually with anything. So you could throw a MongoDB, the native driver, at us, and it will work. So, and that will allow us to also filter things. We should be very careful with that, because we don't want to create another SQL here. But it's very useful if you have this view where you want to filter certain things or sort certain things. So we should be careful with what we allow to filter, but it's a very easy way to very efficiently fetch from GraphQL to your data layer. Let's quickly do that. So I'm adding just here a couple of middlewares on top. So with that, a use projection, then a use filtering, and then I'm doing use sorting. And then by default, these features are disabled. So because we don't want to overexpose things. So you can opt into them. So I can say add projections, add filtering, and then add sorting. And then we can just restart our function here. Go back to our browser, refresh that. And now we have actually a couple more properties on here. Let's have a quick look. Oh, no, I broke something. That will be difficult because it's so small, the screen. Where's my mouse? I don't see my mouse. Ah, there. Thank you. Pardon? 44. Ah, there's something not right. Let me just kill that. Let's try that again. If it doesn't work, let's move on. Could be the Azure connection. Executing exception while function is executed. Aggregate exception. Schema for more looks. Errors property. Okay, I'm skipping that. It will work. I made a mistake, but it's too difficult on this small screen to fix. Okay, so this would be data aggregations. Let's move to real time because that's even more interesting to do. Okay, so that's something that we talked for so far about fetching data with queries. Now we are going to subscriptions, and this is something that was very difficult with Azure Functions. And why this is so difficult, I explain you in a second. So subscriptions have a different concept in GraphQL. So we are not just executing a resolver and getting a single result. We are actually subscribing to something that we call the event stream. And the event stream, every time it's triggered, we run the GraphQL engine to fetch data and aggregate data to you and send that down to you. So typically, we would do that with WebSockets. And that is very efficient if you use ASP.NET Core. And then you could use something like Azure Web PubSub or so if you want to go for real scale. So typically, when we look at something like this, an event stream would trigger and would produce events. And on top of that, we put our executor. And the GraphQL executor, every time there's an event, would run and then execute the query that is requested from us and send that down to our user. Okay, let's have a look at how that actually works. That's strange. Okay, I'll fix that in a second. Let me just get rid of that. And then we go to example 6. Okay. Good. Okay, so this is again an Azure function. This time I'm using the in-process mode because I want to have streams and I want to have control over cancellation. It looks a bit different. So if I go here in the startup, you can see it looks more like the old ASP.NET Core. So we actually have a builder. We don't have a builder because in-process mode is essentially in DLL. So the difference between in-process mode and out-of-process mode, with out-of-process mode, I actually have a console that I configure and that runs. So how that works is actually the function always starts and it starts a console and communicates between these two processes. So with in-process mode, I'm a DLL that is loaded into the main process, and that gives me also more freedom to do things. Let me just quickly restore that. Restore. Okay. So I have so far a query type that just says hello. We are not interested in that. We are doing the typical thing here for GraphQL subscription, and that is we're building first a mutation that does something, and actually this mutation will trigger an event that I can listen to. In this example, we have a mutation that is called publish book. So we essentially can create a book or publish a book. And then every time there's a book published, I want to subscribe to this event and get notified that there is a book published. So I would first put something else in here. So this actually does nothing. So usually you, you would have somewhere here your data layer that actually saves this book or does something with it. The next thing we would need is something to trigger an event. And we call that in Hot Chocolate the iTopic event sender. So this is our abstraction to send in events to our subscription system. So let's call that event sender. And this is a service. So I'm marking this with the service attribute here, so that the GraphQL engine knows that it's actually not a standard argument, it's actually a service. And next we can just publish here. So we are taking the event sender, and then we are using the name of the method in this case as a topic. You can use anything, you can even use objects or ints as a topic, and then sending in the book. In a real-world application, I wouldn't send the full entity. I would probably just send an ID because I don't want to overwhelm my pub subsystem. In this time, I don't care. I'm just sending the whole entity. Okay, so the mutation actually is now done. Every time I publish a book, I'm triggering this event stream. So now I can create the subscription here. And the subscription essentially is this thing that is triggered every time something goes on this event stream. So I'm creating a new method here called onPublishBook. So this is always triggered when the event is triggered and somebody is actually subscribed to it. Otherwise, we will just throw away the event. So in order to make that clear that this is a subscribe resolver, we annotate it with subscribe. The next thing that we do is introduce a topic here. So we are saying that this subscribe method listens to this topic. And then we need one more thing, and that's our event message. So we say we consume an event message here, and this event message is actually the book that we just created. And then we just return it. So typically, if you build real subscriptions, they're actually a bit more complex, right? Because, let me just get that in. Because typically, you just get an ID, and maybe you think about things like replayability, and then we can use something like an async enumerable as a stream. I can show that in a second after we get the basics right. Okay, so this event is now set up. Let's have a look at the startup again, and I'll walk you through a bit. So we have the mutation type here, and that is just my other root type. You can see we can have 3 root types, and now we have all the 3 root types registered. Second thing is I'm using here the mutation conventions. That's just so I have a nice GraphQL mutation structure. And last but not least, I'm using here the add in-memory subscription stream, and that's my in-memory pub sub. In a real-world application, I would use something like NUTS, which is scalable and synchronizes my functions, or something like Redis as a pub sub. But just for the demo, this will work. Okay, and then it's not .NET Run, it's func start. Function is coming up and is doing something. And I actually wrote a little .NET tool here. Let me notch this one up. It's nothing fancy. It is just a console that will now subscribe. It's connected actually. And it's now subscribed to our event stream. Let me put that here. And then we can take actually banana cake pop again. Let me make that small and rearrange that here a bit. And okay. Okay, we are online. So I created a couple of books here, or queries to create books, and let's just run them. And you can see the events are immediately coming in here, and that is with Azure Functions and GraphQL SSE. You can use GraphQL SSE just in your client applications. And let me just show you there is. So if you're using JavaScript, yeah, so it's this component actually. Let me make that bigger. And this works well over HTTP 2. We don't support the HTTP 1 version for this. So if you are using HTTP 2, it will work well. Otherwise, I would use a different solution. So there's GraphQL SSE, standard component. Hot Chocolate is implementing that. We're also supporting GraphQL WS, which is the WebSocket variant. Let me just get back to my slides here. And I want to this slide, because then I can walk you through a couple of tidbits here. Okay, this one I want to have. And then let's make that big. Yeah, we have seen that. Damn it, I cannot abort it. Okay. So this is what we build. So we use the GraphQL function, and there, when you scale it, there could be hundreds. And then we use GraphQL SSE to directly subscribe to the function. That means all the functions to which you are subscribed, they cannot retire anymore until all of the subscribers are gone from this particular function. So it might be that you have a lot of functions after a while. So maybe you have a routine to kick them off after a while. We have an interception point for that. You could say maybe there's no subscription that is allowed to go beyond 4 hours, and then you have to reconnect or something like that. There's a second thing here. I added there nuts and Redis. So we would want a pub subsystem, because if somebody is running a mutation on this one system that causes on another Azure Functions instance an event, we need a pub sub that works between these functions. And that could be nuts or Redis, because they are a they have this fan-out mode where you have one-to-many. We could also have a different setup that is more complex, but that would also work with the isolated mode, and that is by using Azure Web Pub Sub. And in this instance, we still would have the nuts and Redis, but we would offload all the WebSocket connections to Azure Web Pub Sub. And then your web consumer would actually connect to that endpoint from Azure. This could be interchanged with, it's not yet ready, it's coming in some of our next previews, with the Azure SignalR Hub, meaning you would use SignalR instead of Azure Web Pub Sub. I actually don't like that so much, because we are now using GraphQL WS over SignalR, but it has some benefits. So if you're going for high performance, then use Web Pub Sub. If you're going more for compliance with older stuff, like long polling, you want long polling in there, then it's SignalR. And if you just want an HTTP GraphQL SSE. Okay, so there are a couple of problems that we face with subscriptions. It's scaling, throttling, and quality of service. What that means is, so scaling with Azure Functions, we solve that. We can scale. And if we put things like Azure Web Pub Sub in, we can also scale. They can go up to 1 million subscribers. So it's a massive scale. But there is a thing about throttling. So you don't want to send maybe every event down. If you have a high frequency event stream, you don't want to send every event down to your client and trigger them and trigger reloads of the UI. You might want to throttle that and send them down in buckets. So if you create an event stream, you could use system reactive to essentially bucket and throttle them down. There's also the question of quality of service. And there we have to think about, what about missed events? Should we replay events? And that works when you use event streams. I quickly can show you how to implement that. So if we are here in our event, we use now this construct, but this is not replayable. We could also have a replayable event that would look a little bit different. So we would, in this case, use an async enumerable, where we pass on the book. Would be called the same. Let's call it the same, just with async, just to have a different name here. And then we could yield now asynchronously data. And typically, async. And typically, we would, in the first part, now look in the database or look somewhere up if there are missed events. and replace them. And then in the second part, subscribe to the real-time part and then yield real-time events. It works like an enumerable. You can just yield return here, right? So this is a very good way to do that. Okay, let's have a look at something new in GraphQL. And we actually implement that for 2 years already, the earliest bits. And that's a really cool feature. Because in GraphQL, we have that problem if we have expensive requests and if you look at GraphQL clients, we actually only want one request to the server for every view. Do I have time? Okay, let me just quickly see if I have a client somewhere deployed. Yeah, that's our typical demo application, and it's really slow because of the internet connection here. Let's go here to our developer tools and notch that quickly up to maybe 200. Okay, that didn't notch this guy up. Okay, but the essence here is every time I reload, no matter where I go in this application, I always have one GraphQL request here, and that is very efficient for network, right? I get what I asked for and I only need one request, no data waterfalls. And if I want to do that, that means if I have slow parts, like let's say the price here is very expensive, then this could slow me down. And with the new GraphQL specification, we allow now to defer or stream these parts. Meaning we can put these inline fragments around them and say this part is actually not so important. Send me all the rest, and then resolve this part later as it becomes available. And this is done over HTTP 1.1 and the same HTTP stream. And we also could do that in a fragment structure like this. And this allows us to break down the execution in the execution engine and actually just send the initial payload first and then send subsequent payloads as they become available. Let me show you that. So this is actually the server for the application that I showed you. And here's our request graph. And if I fire that, I get a response here. And I actually get a single response. Let me make that big. So I get a single response here. I can look at the logs here. You can see I have one single response. And when I now introduce defer here, now this whole thing, or let's just defer this part here. Now we're deferring the most expensive part of our request. It's actually, this guy is actually in the implementation resolved through REST in the backend. And now the execution is split down, but I can go one further and say, okay, this actually is a list. We could also stream that at the same instant, but send me down the first item. I need one item to display my client, and all the rest data send me as it becomes available. And now I can run that, and you can see, you saw for a second this flickering there. Let me do it again. Yeah, it flickers too fast, but we luckily have this lock here. I can jump to the newest here, and you can see that actually we sent down multiple parts. So we initially just get this response with this first item, and then we get other parts from the query, like let's take the fourth part, for instance, is the fourth item from our list. And as we go along, you can see there are the more expensive parts that are patched down and become one result. And that's actually what our application also does here. It streams these data. And let me show you one thing here. Because when you design your web application, look here, there are multiple graphs here. And no matter how I refresh this application, It's really slow. But they are immediately there. Although this is streamed, this becomes available later, but for the human eye, it's immediately there. You don't know that it's actually there, but as soon as you swipe, it is there. So you can analyze how your application needs data and defer it, and still use a single HTTP connection. Okay, let's go to the conclusion. So, serverless simplifies your deployments, simplifies how you think about applications. You essentially can now focus on your graph in GraphQL, focus on your application logic, and you don't worry about scaling. It just scales. On top of that, we can control our costs and pay only what we use. And with GraphQL rapidly evolving and getting new features, we are actually good served with GraphQL. So one more aspect. So when I started with GraphQL in .NET, it was nobody knew about it. But now it's rapidly adopted by companies. Microsoft Nougat internally now uses GraphQL Hot Chocolate. Microsoft Office also starts using Hot Chocolate internally. So there is a lot of GraphQL coming out of Microsoft. Teams, for instance, uses GraphQL as a backend publicly already. So you can see that in the .NET ecosystem, it's more and more adopted and getting more and more mainstream now. So try play with it around. It will change your life. It changed mine. So with that, I'm done. If you like our project, start us on GitHub. And if you have questions, you can shoot.